In this lecture, we're going to activate a power-up when the player touches it. In this lecture, we're going to activate a power-up when the player touches it. We're also going to learn how to return variables from methods in order to write cleaner code. Let's jump right. In this lecture, we're going to activate a power-up when the player touches it. We're also going to learn how to return variables from methods in order to write cleaner code. Let's jump right into it. Last lecture, we set up these scriptable objects for our power-ups. Now, let's create the logic part of how these power-ups should work. First, let's start by making the object that we can collect in order to activate the power-up. Inside of the sprites folder, we have a gift bag that we can use as our sprite. So I'm going to drag the gift bag into my scene, and I'll call this power-up in the inspector. Now, let's go back to our scripts folder and create a new script for this object. I'm going to right-click, go to Create, and create a new mono behavior script. And I'm going to call this power-up manager, because it's going to manage the power-up object and contain all of the logic for our power-ups. Before I forget, let's select the power-up object and then add the script as a new component. Now let's open it up. Inside of the script, script, I'm going to start as usual by removing the start and update methods. With that out of the way, how exactly are we going to make PowerUp Manager access all of the data inside of our PowerUp scriptable object? To access the scriptable object is actually very simple. We'll create a serialized field of type PowerUp_SO, which we'll call PowerUp. And now we can drag our scriptable object straight into the inspector. So back in Unity, I'm going to open the PowerUps folder, and you might have noticed that some of my PowerUps have disappeared from the last lecture. That's because Unity hasn't properly saved my project, so always make sure to save yours. Anyway, that's fine, I'm just going to drag short speed into the PowerUp serialized field. And you can also click on the circle at the right of the serialized field in order to quickly select from all of the available power-ups. So you can start to see why separating your data is so useful. We can easily find them in our file system and swap them in whenever we need to use them. Since we want the power-up to detect when the player touched it though, we probably want to add a collider. So I'm going to go ahead and add a new box collider 2D. The size of the collider looks about right to me, so we probably don't need to mess around with it. I am, however, going to turn on isTrigger so that the player can go through it after touching it. Now that our object has everything needed in order to work, let's get back to our code. Back in the PowerUp Manager script, let's detect when the player touches the power-up. So I'm going to write void onTriggerEnter, and of course VS Code is going to forget a few letters, so let me just fix this. And before we write any more code, we need touches the player can go through it after touching it. Now that our object has everything needed in order to work, let's get back to our code. Back in the PowerUp Manager script, let's detect when the player touches the power-up. So I'm going to write void on trigger enter, and of course VS Code is going to forget a few letters, so let me just fix this. And before we write any more code, we need to make sure that it's the player that's actually touching this power-up and not anything else. So I'm going to cheat a little by opening the finish line script, and I'm simply going to copy-paste the code that we're using to make sure that it's actually the player that's touching this object. So I'm simply going to copy this code from onTrigger enter and paste it in here, and I'll remove all of the extra lines that we don't need. Now that we're sure we're actually touching the player, inside of this if statement, we want to activate the power-up as soon as we reach this part of the code. The power-up will change some of the variables inside of our player controller, whether that's increasing the movement speed or increasing the torque. Because of this, it might be awkward to manage all of the player variables from someplace outside of the player itself. Therefore, we should actually activate the power-up inside of the player controller script. So open up your player controller script and scroll all the way down. And let's create a new public method called activatePowerUp. This is going to check the type of power-up we have and apply its effects to the player. But how do we know which power-up to activate? Let's create a new public method called activatePowerUp. This is going to check the type of power-up we have and apply its effects to the player. But how do we know which power-up to activate? Well, the power-up manager script will need to give us some information, so I'll need a parameter. And the parameter we need is actually quite simple. We'll take the power-up itself into this method. So the parameter that we're going to use is the power-up SO itself. The power-up scriptable object already has all of the data we need. And since it's a scriptable object, we can easily pass in the entire data container. This is much cleaner than, say, having to pass in every variable inside of the power-up one by one. So let's head back into our power-up manager script and call the activatePowerUp method. We'll need to reference the player though, so I'm going to write player controller player add. the top, and as soon as the game starts, I'm going to find the player similar to how we've done this in the past. So the player is going to be equal to find first object by type player controller. Now that we have the player, as soon as it touches this object, I'm going to run player.activate powerup and give it the powerup that we currently have selected inside of this powerup manager. And this is simply going to give our scriptable object, which is all of our data, into the player controller. This is great, but there is one problem. If you look at our powerup SO script, none of these variables that we're trying to use are public. These variables are all private by default, meaning that we can't actually use them in our activate powerup method. I also did say that it's a bad idea to make these variables public, since we don't want anything to accidentally set these variables. So you wouldn't want any other script to be able to change the powerup type, for example. In order to access these variables without writing messy code, let's learn something new called returning variables. Returning a variable means getting a variable back after running a method. And an example for this would be mathf.deltaAngle, which we've used before. This method does some calculating behind the scenes, then returns an answer to us. We take the answer that it returns and put it back into a variable. So in this case, this method returns a float, which we put inside of a variable like angle. Another example would be find first object by type. It finds the object and then returns it to us as a variable. We can make our methods return a variable as well. Have you ever wondered why all of our methods start with void? So for example, void rotate player or void activate powerup and so on. Void in this scenario actually means that our method does not return a variable. So we can't do int x equals rotate player, for example, because since rotate player is void, it doesn't return a variable to us. We can, however, replace void with the type of variable that we want to return. Here's an example. This first method, called returns 5, has int at the start instead of void. That means that this method returns an integer instead of not returning anything at all. Inside of the method, we can return any integer, but to keep things simple, it's only going to return 5. Now, in our start method, we have an integer called x, which we're going to set to be equal to returns 5. So it's going to take what this method returns and put it inside of an integer called x. Therefore, x is going to be equal to 5. So why exactly are we going to use this returning stuff? That's because rather than making our variables public, we can make methods to return these variables for other scripts to use. And one of the main benefits of doing that, like I said before, is that it protects our variables from accidentally being set by other scripts. This is actually a concept in programming called encapsulation, which is a very fancy word of saying keeping your variables private and only accessing them through methods. Anyway, let's head back to our powerup SO script, and I'm going to create a new public method, which returns the first variable, which is a string. And I'll call this getPowerUpType. And as soon as we create this method, it's going to cause an error. It's saying that not all code paths return a value. We said that this method returns a string, therefore we have to return a string at the end of the method, otherwise it's causing an error. So the only thing I'm going to do is that I'm going to return power-up type. Now any other script can access this method and get the power-up type from any power-up. We'll do the same for the other variables, so I'm going to create another public method that returns a float this time. This one's called get. Value change, and obviously it's going to return value change. I'll create one last one for our third variable, also going to be a float to match our third variable, which is time. So I'm going to return time. These methods that return private variables are actually a common thing you'll see in programming. We call these getter methods for short.
Taras Massepases, vinkande hand.
Hello.
Anyway, I'm going to return time. These methods that return private variables are actually a common thing you'll see in programming. We call these getter methods for short. Anyway, now that we created some getter methods, let's head back into the player controller and get back to working on our activate power-ups method. This is probably simpler than you think. We're just going to check the type of the power-up and
Taras
depending on
Massepases,
that, change a few
still doing
variables.
letters.
Hmm. Well, I guess.
So I'm going to create an if statement checking if the type is speed. So I'll write if powerup dot get powerup type is equal to the string speed, then we're going to make our player faster depending on value change. And yes, string references are something that should be avoided, but I really don't want to make this any more complicated than it has to be. So this is just going to get the powerup type and check if it's currently speed. If it is, then we're going to increase our base speed by powerup dot get value change. So our value change is currently 10, therefore it's going to increase our base speed by 10 as well. While we're changing the base speed, let's not forget to change the boost speed as well, since that's a separate variable. I'm also going to increase it by powerup.getValueChange. And that's it. Hopefully, as soon as we touch this power-up, it's going to increase our speed by the value change that we have set. So let's hop back into Unity and make sure that this actually works. Now, as soon as I run the game, the player is going to move normally at first, but as soon as we touch the power-up, the player is going to suddenly be so much faster. We're going to make it have a timer in the next lecture, but for now, it just working is good enough. And that brings us to your challenge. I'd like you to create a power-up of type Torque if you haven't already. We've done this in the last lecture, but mine got deleted. Then, make Activate Power-Up increase the player's torque by value change. This is, of course, if the power-up type is currently Torque. Finally, switch the power-up scriptable object that we use in our game to the Torque one. So go ahead and pause the video to take on this challenge, and I'll see you in just a bit. Alright, excellent job with that challenge. I've recreated the short torque power-up that we had in the last lecture. It's a torque power-up with a value change of 10 and a time of 2. Now let's quickly select the power-up object, and I'm going to drag in this short torque power-up inside of the power-up manager. And finally, I'm going to open up my player controller script, and I'll make a new power-up object, and I'm going to drag in this short torque power-up inside of the power-up manager. And finally, I'm going to open up my player controller script, and I'll make a new else if statement, checking if the power-up dot get power-up type is currently equal to torque. If it is, then we'll simply increase our torque amount by our powerup.getValueChange. So the code is basically the same as the if statement above, but I'm simply changing a different variable. Now let's head back to Unity, and as soon as I start my game and touch the power-up, I should hopefully be spinning a lot faster. I think I was spinning faster, but I'm not really sure. So let's go to the short torque power-up, and I'll make the value change 100 instead of 10. And as soon as I spin, whoa, I'm spinning maybe just a tiny sure. So let's go to the short torque power-up, and I'll make the value change 100 instead of 10. And as soon as I spin, whoa, I'm spinning maybe just a tiny little bit too fast. But at least I now know that the torque power-up is working just fine. I'm probably gonna stop the game and set that back to 10. But that is going to be it for this lecture. We learned how to return variables in order to write cleaner code, and how to activate our power-ups as soon as we collect them. So excellent work with this lecture, and I'll see you in the next video. In this lecture, we're going to activate a power-up when the player touches it. We're also
Okay, done today.
Alright, I'm going to bed. Thank you. Here.
Bye.